Hey everybody, Trey here. Welcome to another forecast discussion. We've got a slight risk out by the SPC today for parts of southeast Oklahoma down through East Texas and into western Louisiana. We'll be accompanied by a tornado threat. Highest probabilities do include the Dallas-Fort Worth metro area and areas to the southeast, including the I-30 and I-20 corridors, east and southeast of Dallas, down toward the Lufkin area. Also, a damaging wind threat and perhaps a significant hail threat. That hatched area down there, including the Dallas-Fort Worth area, does suggest the possibility for hailstones over 2 inches in diameter. So, all severe hazards on the table today. Severe weather season is ramping up. It's the middle part of March. We're going to start to see these severe weather setups a little bit more frequently. So let's discuss what we've got going on today. Let's take a look at our water vapor imagery here. And you'll notice this pretty well-defined swirl here in the satellite imagery here. That's going to be our main player for today. You'll notice it's already kind of ejected well into the southern plains already. Usually we see kind of the trough hanging out here over the western half of the continental U.S. Starts to eject into the plains by the morning or the afternoon of the day of the event. Not the case here. It's pretty much already ejected into the plains. What's going to happen though throughout the day today is it's going to move east a little bit, but it's going to dig a little bit more deeply down to the south. And as that happens, the exit region of the trough, most favorable area for lift, as far as where the placement of the jet axis is, will be somewhere over our slight risk area, somewhere over our target area, and areas out to the east, Louisiana, Arkansas, maybe into Mississippi. Exit region will be there, of course, focused here on East Texas into southeast Oklahoma today. And this is going to be evidenced by our 500 millibar map here. This is our mesoanalysis for the 500 millibar flow here on the SPC site. And you'll notice that we've got this trough here positively tilted at this point with all the strongest flow kind of relegated to the backside of the trough here at this point. That should round the base of this trough a little bit as we go toward today. But we're really not going to see this trough go pretty strongly negatively tilted. And we talked about this before. When you have a positively tilted trough, most of the strong winds kind of remain toward the backside of the trough. Suggests that it's not really super mature yet. Whereas if you have a negatively tilted trough, if we had these height contours kind of oriented this way, so your axis of the trough was like this, negatively tilted back toward the west a little bit, that usually means your trough is a lot stronger and the lifting is going to be maximized. Everything that comes with a trough, that lift, that vorticity, the spin in the atmosphere, going to be maximized in that exit region. But we really don't want to overlook positively tilted troughs. They can do the exact same things that negatively tilted troughs can do. Because we do have strong flow on the backside, it's going, again, to round the base a little bit as we go through the day today. And it's going to deepen a little bit. So we're going to have a potent trough regardless of the tilt of the trough. And we're going to have a pretty strong flow here into East Texas by this evening. And we're going to have very cold air aloft. You can see the air associated with this trough here. You can see these red dashed contours, minus 24 down here, minus 22, so very cold air here associated with the center of this trough. So this may act a little bit like a cold core system. We talked about this with our last system, that localized tornado outbreak in Iowa back on March 5th, where we talked about these kind of cold core setups where you have very cold air aloft and you don't have a ton of wind shear in our target area, but the cold air aloft from this trough helps really destabilize the atmosphere quickly. With strong instability in the low levels, will help stretch any low-level shear that happens to be there very efficiently. Well, in this case, we're going to have some shear. You can see this belt of strong flow going to, as we said, impinge on East Texas by this afternoon. If we go to our 700 millibar flow, again, positively tilted here. There may be a little bit of a shortwave out in here. Perhaps this is kind of the axis of the trough here, one on the backside. Little kind of kinks in the flow there. If we go down to 850 millibars, we're going to have a pretty potent low-level jet in place already. 40 plus knots of flow throughout, even as far up to southern Iowa, down through central Texas, into East Texas there. This is going to wane a little bit throughout the day, but it's going to hang on just enough here throughout the parts of East Texas into southeast Oklahoma that we will have strong flow in place. So the photograph should be relatively large and looping by late this afternoon and early evening. So we will have a lot of shear in play, and as that cold air moves in aloft, we should get rapid destabilization to occur. Let's take a look at the surface here. Let's see how our moisture return is doing. We'll take a look at some soundings in a second to see the quality of this moisture. But if we look here, we can see our 50s dew points relegated. They were actually already up pretty far, actually farther than I thought this morning. They're just south of the I-20 corridor here. You can see 54 there, right here, 54 here, and areas to the south. There's kind of our 55-degree line there. So our moisture is still confined to East Texas, hasn't really made its way up to the north too much yet. But again, as this surface flow continues to be out of the south throughout the day, we will get that moisture to continue to be pumped northward. And you'll see our surface low here, sort of in the southeast Kansas area. Kind of hard to make out here, but there is a surface low down in there. Wind shift here, kind of a cold front. You'll see that the temperatures here on the backside of the front are not super cold. This kind of frontal zone is more Pacific oriented in nature, what we call a Pacific front. So it's the cold air. It's not kind of the boundary between really cold Arctic air from the north. It's really taking that air from the Pacific and bringing it into the U.S. So we're not really seeing a temperature difference so much across this front. Temperature is actually even a little bit warmer here on the back side of this front. This is more of a Pacific front or pseudo dry line here, if you will. So because of that, I don't know that we're going to see this front really start to surge. Often when you have really cold air behind the front, that front will really start to surge. But I don't see that being the case today. We've got pretty potent southerly flow here on the east side of the front, northerly winds on the back side, but not really cold air. So I don't think the front is going to move super fast throughout the day today. So we won't have a ton of overwhelming frontal forcing. Often when you have a lot of frontal forcing, you'll get just a million storms to go up along that front. They'll either get undercut really quickly with a tornado threat that will be negated, or you'll just see a million storms go up and more of a linear storm mode. So I don't expect there to be a ton of frontal forcing today, just given that the lack of super cold air behind this front, but something we'll have to watch throughout the day. Let's take a look at the quality of this moisture. Again, 60s dew points confined to the coast, mid-50s all the way up, almost to the I-20 corridor. Let's take a look at some soundings and see the quality of that moisture. So let's go down to Corpus Christi here. So we've got a pretty deep moist layer, pretty stout inversion here at the surface, 41 degrees dew point there right at the surface. So, but I would assume areas a little bit farther to the east here, Houston, Galveston, right along the coast, going to have a much higher dew point as we saw on our surface map. So not super concerned about that right there, but just looking at the extent of the moist layer here, it does extend up fairly deep, up to about just above 850 millibars. So decent moist layer there, a little bit of a dry slot here aloft. Some fairly warm temperatures, steep lapse rates aloft here. So we're going to have a pretty stout cap in place, I would expect, throughout much of the day. Let's go to Dallas-Fort Worth here. And lots of dry air aloft. Very dry profile here above about 850 millibars. You can see that moist layer does extend up to about 850 millibars. But we've got very warm, dry air here aloft. You can see the dew point trace and the temperature trace here separated by quite a lot. So we're going to have a very, very stout cap in place throughout much of the day today. But again, as that really cold air aloft starts to impinge on the region, if we go to let's go to our Midland sounding here. Actually, let's go to Albuquerque here. No, let's go to Amarillo. You can see here's our minus 20 degree isotherm. And you can see right about 500 millibars is that minus 20 isotherm. So very cold air aloft lurking just to the west here. Once that cold air arrives in the region, we should get a rapid erosion of this cap, and we should get rapid destabilization of the atmosphere once that cold pocket aloft moves over East Texas by this evening. All right, let's take a look now at some of the models. We'll take a look at the NAM first. And lately we've been kind of neglecting looking at different model runs just in the interest of time. But the NAM did so bad on the last setup, the Iowa tornado outbreak, really sapped the instability the night and the morning of the event, the night before and the morning of the event, that we're going to look at the NAM and the RAP here just to kind of give two looks at this. And then we'll take a look at the cams quickly to end the video. But we'll take a look at the NAM here, try to get the overall pattern. And you'll notice we have our trough here. Winds kind of relegated to the backside of this trough. But it does kind of dig a little bit more deeply here. This is by 0Z tonight, so this would be 7 p.m. Central Daylight Time. And you can see that belt of winds, belt of enhanced flow there around that trough does round the base of that trough. Still somewhat positively tilted by this evening, but very nice defluence or spreading out of the wind vectors in the exit region of this trough. When you have the spreading out of wind vectors aloft, you get rising motion. If you can kind of picture the air aloft as it spreads apart, it kind of leaves a gap in between of pretty much nothing. So what does the atmosphere do to fill that gap? Well, it brings air up from the surface, from below to above. So you get rising motion where that defluence is greatest, and that is going to be right smack in our exit region of the trough. Very nice defluence there. So we should have a lot of lift in that exit region of the trough. With northern extent, the 500 millibar flow does wane a little bit. So the shear should be a little bit weaker here with northern extent into southeast Oklahoma. Strongest here toward East Texas, down toward Tyler, Longview, and areas to the south toward Lufkin. If we go down to 850 millibars, actually let's first look at our 500 millibar temperatures, and you'll notice just how cold that air is aloft. By 0Z, we've got these grays here, these mid-grays, above minus 25 degrees Celsius. That is extremely cold air aloft here, all the way into parts of east and northeast Texas, I-20, I-30 corridors, Dallas-Fort Worth, up to southeast Oklahoma. So very cold air aloft should rapidly destabilize the atmosphere once it moves into the region. Let's go to 850 millibars here. And you'll notice we have our pretty potent low-level jet here, as we saw on our 850 millibar mesoanalysis map. But that does kind of wane a little bit throughout the day, but we do have enough of a pocket here across parts of eastern Oklahoma down through East Texas here, 30, 35, 40 knot winds here, that we will have a little bit of that low-level jet hang on. Should have decently large looping hodographs here, given this strong belt of flow here, about 1 kilometer above the surface. If we go forward in time a little bit more, you'll see that low-level jet does hang on just till sunset, through sunset, after dark, and then it kind of moves off to the east as we kind of get a consolidation of the surface low here. Let's look at our surface pattern. So you'll see here's our surface low right now, kind of our Pacific front here stretched southward like that. But you'll notice not a whole lot of super cold air on the backside of that front, as we saw. So we're going to get by 0 to 3Z, just right before sunset, just after sunset, we're going to get this consolidation of the surface low here in northeast Texas. Wind should back a little bit more just to the east of that surface low. Pretty broad, warm sector here. And so we shouldn't have too much of an issue with backed winds in the low levels. We should maintain those large looping hodographs at least through the few hours after sunset. Let's take a look at our moisture here, our dew points. Let me zoom in here. Oops. Let me zoom in to the southern Great Plains sector here. So again, the 60s confined to the Texas Gulf Coast there, but they will stream northward fairly quickly. But this is going to be a case of what we call just-in-time moisture, where the best moisture arrives right as the best lift and instability impinge on the region. but we will have enough, and this is much improved over the last few model runs. The 60s get all the way up just to the east of Dallas-Fort Worth here, toward the Canton, Texas area, I-30 corridor. And that is an improvement over the previous model runs, I believe. Let's take a look. Let's go back. So this was 12Z on the 11th. This was a few days ago. Didn't even have the 60s getting even close to the I-20 corridor. As we have gone along, they've gotten a lot better here. And so this was the 12Z run yesterday. So the morning model run yesterday. You'll notice the 60s dew points don't even get close again to the Dallas-Fort Worth area. We got mid-50s kind of up toward kind of the Sulphur Springs, Mount Pleasant area here. But the 60s really hang out south of Tyler, Longview, down toward Lufkin. And as we move on throughout the day, even like last night's model run didn't really have strong enough moisture advection here. But as we go through as we see this morning's run, a pretty big improvement in the moisture. The mid-50s get all the way to the Red River. 60s get just to the east of Dallas-Fort Worth, and extend all the way south toward the Texas Gulf Coast there. So that is a concerning trend for East Texas here. We do have a lot stronger moisture advection, which could lead to a little bit more of a moist profile, a little bit more instability for these storms to work with here this evening. So let's take a look. Let's take a look at some sounding. Let's go first. This is going to be at 0Z. I think storms will probably initiate. That cap will probably break probably late afternoon, maybe at the earliest 4 to 5, and we'll start to see storm initiation around then. Storms probably won't start to really get going until about 0Z towards sunset. So let's take a look here. We'll take a couple soundings here. So first one we'll look at is going to be that far southern Oklahoma area. And you'll notice that we've really gotten rid of that cap fast, that the upper levels have really destabilized. You'll notice our 500 millibar temperature, probably about minus 23 here. So very cold air aloft has overspread the area. We do have large looping hodographs here in far southern Oklahoma. Effective SRH well exceeding 250 meters square per second squared. Very steep lapse rates aloft. Well over 8 degrees Celsius per kilometer, so very steep lapse rates should provide a significant hail threat, which is why the SPC has hatched that area from far southern Oklahoma down through East Texas there, including the Dallas-Fort Worth area. Very, very steep lapse rates aloft. So that those updrafts will be very strong. They'll be able to loft those hailstones high up into the updrafts, and once that will allow them to get pretty big before they fall out. So we could have some significant hail, maybe even baseball size plus hail today with some of these storms, at least early in the convective life cycle. Down toward Dallas, even more instability. You can see almost 2,000 joules per kilogram of mixed layer CAPE here. Very steep lapse rates aloft, once again approaching 9 degrees Celsius per kilometer. That is insane. That is really, really insane. Low-level lapse rates very steep as well. And I would imagine that the surface temperature may be a little bit cool. I would expect, given the propensity for clearing here, I don't see a ton of clouds here on the satellite image. If we zoom in here to our Texas sector, not a ton of cloud cover here this morning. So I would expect this to kind of burn off throughout the day. So we should get a good amount of clearing here. So I would expect these temperatures to be quite a bit cooler than what they will be. Probably going to get into the low 70s. So they'll possibly be even more instability than what this is showing, which is concerning for the hail threat. We could see very, very large hail today, perhaps even greater than 3 inches with some of these storms early in the convective cycle. But large looping hodographs here in the low levels. There is a little bit of an inflection point here at about 2 to 3 kilometers, about 3 kilometers above ground level here. Shouldn't be too much of an issue. I always look to see if that inflection point, the back veer, so to speak, the backing is above the effective inflow layer. That's kind of a rough guide that I use to see whether or not it's going to be detrimental to the setup. And it does look to be above the effective inflow layer, so I don't think it'll have too much of an influence. Perhaps any supercell that does develop the mesocyclone might get a little bit rain-wrapped, as it will kind of move into its own forward flank precipitation core, as the precipitation will kind of be vented toward the direction of storm motion there. So something to watch for sure, but nonetheless, large looping hodographs here in the low levels. Very steep lapse rates aloft. So I think the main threat with these storms is going to be very large hail today. We'll go farther south here, much of the same steep lapse rates aloft, large looping hodographs here. Let's move on a little bit toward 3Z. It will allow a little bit more of moisture advection, a little bit more instability to build given that moist advection. So we'll go southeast Oklahoma here, do Dallas-Fort Worth, just east of Dallas-Fort Worth, and we'll go down toward farther south deep into East Texas here. So this is southern Oklahoma. That doesn't, see, NAM here is a little bit off its rocker, perhaps not quite sure what it's seeing here. So this was taken in convection here. This would be the Dallas area sounding just to the east of Dallas. Lots of convection ongoing here. So the NAM does have storms ongoing. This is farther into East Texas, still large looping hodographs, a little bit more backing in the mid-levels here. But overall profile does suggest a tornado threat, mostly a large hail threat with these storms. And once these congeal kind of into the line, once that front kind of moves off to the east here, we will get more of a congealing sort of storm mode, more of a damaging wind threat. Let's take a look at the wrap here, see what differences it has. I'm going to keep it on this sector here just for ease here. You can see 500 millibar trough. The main flow goes pretty far south here, but we do have very nice defluence here in the warm sector, or in the exit region, excuse me. A little bit of a positively tilted trough. Very cold air aloft, though. Once again, that's not going to be debated by the models here. Very cold air aloft will rapidly destabilize the atmosphere once it moves in. So low-level jet here, 850 millibars. You can see that pocket of flow. Wrap kind of saps the low-level jet here by evening, whereas the NAM kind of had a pocket hanging on through and after sunset. The wrap doesn't really have that. It has about 30 knots, which is adequate for tornadic supercells, but definitely a little bit less there, so that'll be something to watch. Surface pattern here, that low kind of consolidates here into North Texas by 0Z, a little bit more well-defined than what the NAM had, but you can see that back flow out to the east of that. And interestingly, and you can see here that the wrap has much higher surface temperatures here than what the NAM was showing. NAM was showing low to mid 60s, wrap showing here we get well into the 70s for parts of East Texas. I think this is going to be a bit more realistic here. So let's take a look at the moisture, and you'll notice that the wrap moisture advection is a lot less potent than what the NAM was showing. The 60s don't even make it to the I-20 corridor here. We have kind of mid 50s here through the slight risk area. Let's take a few soundings here. 0Z, we'll go southeast Oklahoma first. We'll take just on the east side of Dallas, and then we'll go East Texas where the moisture is a little bit better. So southern Oklahoma, you can see a lot less instability here, a little bit worse low-level moisture, but again, lapse rates are quite steep aloft, exceeding 8 degrees Celsius per kilometer, so large hail definitely a threat here. Large looping hodographs here, adequate for a tornado or two. Same thing down toward Dallas-Fort Worth. Instability is a little bit better down here with a little bit steeper lapse rates aloft, so a large hail threat for Dallas-Fort Worth very much in play. And then farther south into East Texas, still the same, still adequate low-level shear, steep lapse rates aloft. But let's go to 3Z here. A little bit later on here, the moisture does make it, the 60s do make it up to Dallas-Fort Worth and areas to the east and southeast. So we'll go Dallas-Fort Worth here, then we'll go kind of just southeast of there. Large looping hodographs is a little bit convectively contaminated here, so the wrap is showing some sort of convection there. Steep lapse rates aloft once again. Large hail going to be the main threat. East Texas, this is less convectively contaminated. Very strong curvature here in the low levels of this hodograph. Very steep lapse rates aloft still. So all in all, I think the main threat is going to be very large hail. I think we could have, I don't want to use the G word, gorilla hail, but I think given the lapse rates aloft on some of these modeled soundings here, I do think that the main threat is going to be very large hail from these storms, perhaps over 3 inches in diameter, perhaps approaching that baseball, maybe even greater category of hail. Low-level shear is there for a tornado threat. Could see a couple tornadoes here, especially early on when the storms are more semi-discrete. And speaking of semi-discrete, let's take a look at the storm mode here. Again, I don't think the frontal forcing is going to be super strong. We don't have, again, a lot of cold air behind this front, so it's not going to surge to the southeast. So let's take a look at the boundary orientation and the shear vector orientation. We'll use the wrap here just because it's already up. But you'll notice here, so this is pretty much what the NAM was showing. Here's our kind of frontal zone here. These wind barbs are our shear vectors. And you'll notice we have a pretty solid perpendicularity to these shear vectors relative to the boundary orientation, especially with northern extent. So I do think that we will see a decent window for discrete storm development, discrete supercell development, given the degree of shear. I do think we will have a window for discrete storm development here. Probably starting right early on in the convective life cycle, probably 4 to 5 p.m. Central Daylight Time, and extending well after sunset, probably to about 3Z, maybe 9, 10 p.m. before things start to congeal into a line as that front moves off to the east and updrafts kind of congeal together. So final thing we'll look at here, we'll look at the HRRR run from this morning. We'll go to the most recent run here, 14Z. Let's go to 13Z, 14Z not quite out yet. So this is, again, just a guess at what the radar is going to look like later on this afternoon. Again, take these with a grain of salt. But this kind of just gives us one picture. And you'll notice the HRRR actually does fire quite a bit of storms early on in the convective life cycle. So that is something to watch. Perhaps the shear a little bit farther north is less strong, so the storms are going to be a little bit less organized, a little bit more multicellular in nature. Perhaps farther south we will see a little bit more of a semi-discrete mode, given the shear is a little bit stronger. But something to watch there for sure. The HRRR really erupts convection ahead of that surface low there near the Dallas-Fort Worth area to start moving off toward the east there. So storm mode very unfavorable for tornadoes there, and even for large hail on the HRRR run. Let's take a look at the WRF ARW, just another sort of convective allowing model here. And the ARW also kind of erupts convection here in a messy sort of configuration early on. NSSL WRF, last convective allowing model will show, perhaps tries to hang on to the discrete, semi-discrete mode here for the first couple hours before really congealing into a line. We'll have to also watch out here ahead of the main band of convection, out here across East Texas, perhaps some more warm sector development, perhaps some more discrete storm development out here in far East Texas, ahead of this kind of band of storms that forms out here. So the convective allowing models, interestingly, are not showing a very favorable storm mode for tornadoes and even for large hail. They really congeal the storms very quickly, so that would suggest more of a damaging wind threat. But I do think there will be a window for discrete storms, perhaps a significant window. The shear vectors are very much perpendicular to the orientation of the initiating boundary for much of the first several hours of the event. So that'll be something to watch. I think the convective allowing models may be overdoing the amount of storms that form initially. So we'll have to watch that for sure. But nonetheless, all severe weather hazards on the table today. Tornado threat here again, Dallas-Fort Worth under the gun, places like Terrell, Canton, down toward Tyler, Lufkin, Longview. You are under the gun for the biggest tornado threat for the day. Damaging winds for that slight risk area, and significant hail. Dallas-Fort Worth under the gun for significant hail as well. Just given the amount of instability and steep lapse rates aloft, I do think we will see some pretty large hailstones with today's event. Down toward, again, same areas, Dallas-Fort Worth, Terrell, Canton, down toward Tyler, Longview, down toward Lufkin. So that's all I've got for now. Thanks for watching, and we will see you in the next video.